Reaching Alpha Centauri with our current spacecraft technology is a massive challenge. Using traditional propulsion methods, it could take anywhere from 1,000 to an astonishing 81,000 years just to get there. That's not even considering the dangers astronauts would face along the way. The vast space between stars, known as the interstellar medium, is still largely unexplored and filled with unknown hazards. But there might be a potential breakthrough. Scientists are now exploring the possibility of using a revolutionary concept called laser sail propulsion. It's being seriously considered under NASA's Innovative Advanced Concepts program, offering a glimmer of hope in this seemingly impossible mission. This new concept, sometimes called swarming Proxima Centauri, involves spacecraft powered not by traditional engines but by lasers. When it comes to crossing the enormous distances between stars, speed, energy efficiency, and minimal mass are critical. Proxima Centauri, the closest star to our solar system, lies 4.25 light-years away. That's around 25 trillion miles, a distance far beyond anything we've ever reached. For comparison, Voyager 1, the farthest spacecraft from Earth, has traveled only 15 billion miles after over 46 years in space. Clearly, the speed we can currently achieve with chemical propulsion is nowhere near what we'd need for interstellar travel. At our current capabilities, sending a large manned spacecraft is simply not realistic. The energy required would be astronomical. Instead, scientists propose sending tiny probes weighing just a few grams. These mini spacecraft would be pushed by high-powered lasers from Earth, using light particles called photons to gain speed. While a single photon has very little momentum, a concentrated beam of them could build enough force to accelerate the probes. However, even with that, the thrust would be weak unless the spacecraft are incredibly light. That's why this mission depends on sending thousands of ultra-small lightweight probes. The plan suggests using a laser system with a power output of around 100 gigawatts to push these small spacecraft to speeds of 10 to 20% of the speed of light. If successful, these probes could reach Proxima Centauri in just a few decades. In fact, the mission might be ready for development by the middle of this century, and if all goes well, the probes could arrive at their destination as early as 2075. This approach could finally let us explore another star system in a human lifetime, something previously thought impossible with current technology. The team behind this ambitious idea has already shown how a swarm of around 1,000 small probes could survive the harsh journey through interstellar space. They've even figured out how the probes could communicate back to Earth across those immense distances. Because of the time delay, about 8 years round trip for a signal, controlling the probes from Earth in real time won't be possible. That's why these spacecraft will need to operate semi-independently. They must be smart enough to navigate space and decide what information to send home without constant guidance. It's a massive step toward truly autonomous exploration. One of the main challenges still to be solved is cost. Building such a powerful laser system is likely to be extremely expensive. The mini probes themselves, on the other hand, might be relatively cheap to mass-produce. Scientists estimate the full mission could be possible with a budget of around $100 billion. While that's still a huge investment, it's considered reasonable when weighed against the potential value of reaching and studying another star system. It might seem expensive now, but the benefits of such a mission, scientific, technological, and even philosophical, could be absolutely enormous. Proxima Centauri, the star this project is targeting, belongs to the Alpha Centauri system. It's a red dwarf star, and interestingly, it has an Earth-like planet orbiting it, Proxima Centauri b. This planet is the closest known exoplanet to Earth. It has a similar mass to our own planet and orbits within the habitable zone of its star. That means there's a possibility it could have water on its surface. Maybe even an atmosphere. If that's true, this planet could be one of the best candidates in our search for alien life. But there's still so much we don't know. Unfortunately, detecting signs of life, known as biosignatures, on Proxima Centauri b is extremely difficult. The main method we use to study exoplanets is called the transit method. That's when a planet passes in front of its star, causing a tiny dip in the star's brightness, which we can detect with telescopes. But Proxima Centauri b doesn't pass in front of its star from our point of view. It's not a transiting planet, so we can't use this method to study it. Instead, astronomers discovered the planet using a different technique entirely: radial velocity. This method involves observing the light from a star and detecting subtle shifts caused by the gravitational pull of an orbiting planet. Basically, if a planet is tugging on its star, the star will appear to wobble slightly. That's how Proxima Centauri b was discovered. Scientists were able to estimate its mass and orbit, but beyond that, we're still in the dark. We can't yet see its surface or know what its atmosphere is like. That's exactly why sending tiny spacecraft there, like the laser sail probes, could be so important. They could finally give us answers we've only dreamed about. In recent years, our understanding of exoplanets has expanded dramatically. The years 2022 and 2023 were particularly significant, with groundbreaking discoveries happening at a fast pace. NASA officially confirmed over 5,000 exoplanets by the end of last year. These planets vary in size, type, and location, from massive gas giants like Jupiter to icy worlds like Neptune, and even rocky planets similar to Earth. And these are just the ones we've detected so far. Some scientists believe our galaxy alone could host more than 1 trillion exoplanets. But among all of them, we're most interested in the ones that might support life. So that leads to the biggest question of all: how many of these exoplanets are actually habitable? Could any of them be potential homes for future humans? Or already be homes to other life forms? Surprisingly, the answer might be yes. In 2022 and 2023 alone, we found at least 5 planets that show real promise of being habitable. So buckle up, because we're about to explore some of the most exciting alien worlds discovered so far. These planets might not just change what we know about space, they could change what we know about life itself. The first planet on this list is Wolf 1069b. That name might sound a little boring, so let's just call it Wolf for now. This planet is located just 31 light-years away, which is pretty close in cosmic terms. A group of around 50 astronomers recently confirmed that Wolf could be a rocky, Earth-like world. They used a technique called radial velocity, just like with Proxima Centauri b. Basically, by studying the wobble of the star caused by its planet, they figured out that Wolf exists and even estimated its size. Turns out it's about 1.3 times the mass of Earth. The galaxy just became a little more familiar with the recent discovery of 2 fascinating exoplanets, unofficially nicknamed Hansel and Gretel. And no, this isn't a fairy tale. These Earth-like worlds are located just under 16 light-years away from our solar system. In cosmic terms, that's basically next door. To put that into perspective, Proxima Centauri b, our previously closest known Earth-mass exoplanet, is about 4.2 light-years away. So Hansel and Gretel aren't just newcomers, they're among the closest rocky planets we've ever discovered. The implications of that are massive. These planets could potentially offer clues about what kind of life might exist out there, and what other Earths might look like. These 2 newly found planets orbit a small red dwarf star, one with barely 1/8 of the Sun's mass. That might sound unimpressive, but smaller, cooler stars actually create better chances for planets to be located within a habitable zone, the region around a star where temperatures are just right for liquid water. Hansel orbits its star in just 10 days, while Gretel takes just over 21 days to complete a lap. That means a year is incredibly short on those worlds. Imagine celebrating birthdays every week. It's wild to think how different time and life could function on a planet where years pass so quickly. The discovery didn't happen overnight. It was made possible thanks to a coordinated effort from an international team of scientists using 2 cutting-edge instruments, Espresso and Carmenes. These are not your average backyard telescopes. They are some of the most precise tools on the planet, designed to detect minute changes in starlight as planets pass in front of their stars or tug gently at them with their gravity. The measurements were so precise, it said they could almost count craters on a planet's surface. Though of course that's a bit of scientific humor. The real achievement was confirming the planet's positions, sizes, and distances from their host star. What makes this even more thrilling is that both Hansel and Gretel lie in the habitable zone of their red dwarf star. That means, in theory, conditions could be just right for liquid water to exist on their surfaces. And since both planets are close in size to Earth, they are prime candidates for future studies on their atmospheres. The lead researcher noted that nature seems to be insisting that Earth-like planets are common, possibly even the rule rather than the exception. With this discovery, we now have evidence of at least 7 planetary systems in our cosmic neighborhood that could support Earth-like conditions. It's as if our neighborhood just got a whole lot more interesting. This discovery is more than just a scientific paper. It's a celebration. It's a leap forward in our understanding of the universe. So, raise a metaphorical glass of space-age water, or whatever exotic drinks aliens might prefer, and toast to Hansel and Gretel, the new members of our local interstellar community. But we're not done yet. Let's move on to another interesting planetary system. Farther out, about 98 light-years away from Earth, lies a planet called LP89-9c, which we'll casually nickname Bob. This world is roughly 40% larger than Earth, and it doesn't travel through space alone. Bob has a twin, a slightly larger exoplanet that we'll call Ray. Ray is about 75% larger than Earth and orbits the same red dwarf star as Bob. Unfortunately, Ray is not very hospitable. Its surface temperature is estimated to be around 253 degrees Fahrenheit. That's more than enough to melt some plastics. So, if you're planning a visit, better bring some heavy-duty cooling gear. Bob, on the other hand, holds more promise. It's situated right in the habitable zone of its star, which instantly makes it a subject of intense interest for astronomers looking for Earth-like conditions. But as always, the devil is in the details. Even if Bob is in the so-called habitable zone, that doesn't guarantee it's actually habitable. Whether it can support life depends largely on the kind of atmosphere it has. A thick atmosphere with greenhouse gases could trap heat and make the planet too hot, just like Venus in our own solar system. Venus is in the habitable zone but is anything but comfortable. It's a sweltering, high-pressure furnace thanks to its runaway greenhouse effect. So, while Bob looks promising from afar, we can't get too excited just yet. Still, hope is far from lost. Enter the James Webb Space Telescope. Since its launch in December 2021, the James Webb Space Telescope has been revolutionizing our understanding of distant worlds. One of its powerful features is its ability to analyze the atmospheres of exoplanets using its suite of spectrographs. These instruments can detect what chemicals are present by studying how starlight filters through a planet's atmosphere during a transit. If we find signs of water vapor, oxygen, or methane, we'll have strong indicators that the planet might support life. Bob has already been listed as the second most favorable terrestrial planet in a habitable zone, an impressive ranking given how many candidates exist. Bob now joins a shortlist of about 7 Earth-like planets within 40 light-years of us, all of which have conditions that make scientists hopeful. Could one of these become our future home? It's a tempting thought. Although realistically, we might want to focus on fixing our current planet before packing our bags for the stars. Regardless, each discovery reminds us of how far we've come and how much there is still to learn. With instruments like Webb scanning the heavens, we can expect many more exciting finds in the years to come. The galaxy is wide and we've only just begun exploring it. It's not just Bob and Ray, Hansel and Gretel, or all the charmingly named exoplanets out there. Think of them like toys on a cosmic shelf, waiting to be studied, understood, and maybe, someday, visited. There are thousands, even millions of planets out there. And each new discovery brings us closer to understanding our place in the universe. With the successful deployment of the James Webb Space Telescope, humanity has entered a new era in the hunt for Earth-like worlds. This mission isn't alone either. Instruments like the Kepler Space Telescope and the TESS satellite have also been critical in identifying potential Earth analogs. So why exactly are we hunting for Earth-like planets? Well, first, because we can. Thanks to major advancements in telescope technology, we can now observe tiny wobbles and dimmings in distant starlight that hint at the presence of planets. These breakthroughs have turned what was once science fiction into scientific reality. When a planet orbits a star, the gravitational pull between them causes the star to wobble ever so slightly. This wobble affects the light the star emits, and until recently, it was impossible to detect. That's because Earth's atmosphere causes stars to twinkle, which masked the subtle shifts astronomers were trying to measure. The real game-changer came with adaptive optics. These are sophisticated mechanisms built into modern telescopes that compensate for the twinkling effect. Mirrors inside the telescope adjust in real time using mechanical springs that shift them by tiny amounts to cancel out the distortion caused by Earth's atmosphere. Once the twinkle was eliminated, the wobble of the starlight became observable. This method of detecting planets is called astrometry, and while the name is a mouthful, the concept is simple. Watch the star, look for the wobble, and deduce the planets. This method has led to the discovery of entire planetary systems that we never knew existed. Suddenly, the notion that our solar system was unique came crashing down. Thousands of planets have now been discovered around nearby stars, and the evidence points toward one unavoidable conclusion. Every star likely has its own planetary system. This realization has sparked a new kind of cosmic curiosity. We're no longer asking whether Earth is special, we're trying to find out just how many other Earths are out there. And we're investing serious resources into this search. The James Webb Space Telescope alone cost $10 billion. The Kepler Space Telescope came with a price tag of $550 million. Even the TESS satellite cost around $200 million. And these numbers don't even include the human side of the mission. The data analysts, the postdocs, the observatory technicians scattered across the globe working at universities, space agencies, and research centers. So when people ask if this search is worth it, the answer is yes, it absolutely is. Discovering another Earth would be one of the most profound moments in human history. we might not be able to visit these distant planets anytime soon. Interstellar travel still requires breakthroughs in physics we haven't achieved. But just knowing these places exist changes everything. It reshapes how we view ourselves and our place in the universe. These planets may have oceans. They may have weather systems, seasons, even moons. They might be completely barren or teeming with microbial life. Every time we discover a new one, we learn a little more about what's possible. It also helps us better understand our own world, what makes Earth unique, what sustains life here, and what might threaten it. The Kepler, TESS, and James Webb missions all use slightly different techniques, but they share one goal: to find another Earth. The method used by TESS is especially clever and revolves around what's called the transit method. It's a game of cosmic shadow puppets. When a planet passes directly in front of its star, it causes the star's light to dim ever so slightly. This dip in brightness can be measured, and it tells us a lot. By knowing how bright the star normally is and how much dimmer it becomes during a transit, scientists can estimate the size of the planet and how close it is to its star. But there's a catch. To gather this data, the satellite needs to observe a star for a long time and from the perfect angle. If a planet's orbit doesn't line up just right, we'll miss it entirely. That's why the TESS satellite observes hundreds of thousands of stars, because catching a planetary transit is incredibly rare. Even Venus only transits the Sun from Earth's perspective every 100 years or so. So TESS takes long-duration video footage of stars using its 4 CCD cameras instead of traditional telescopes. The more stars it watches, the higher the odds of spotting a transit. And that means that for every planet we do detect, there are likely many more that we've missed. Statistically, this suggests that nearly every star has planets orbiting it, even if we haven't seen them yet. The universe is absolutely teeming with worlds. Everywhere you look, scientists are holding their breath. The James Webb Space Telescope, with its massive 21-foot 4-inch wide mirror, is now entering the final phase of its mission preparation. It's not just a telescope, it's a marvel of modern science, a monument to engineering brilliance. The anticipation surrounding this launch is immense. But with all that hope and excitement, there's also fear, real fear. We've seen what can go wrong. When the Hubble Space Telescope launched in 1990, its mirror was flawed, resulting in blurry images. It took a daring 1993 repair mission to correct the problem. But that luxury doesn't exist with Webb. Unlike the Hubble, which orbits the Earth and is reachable by astronauts, the James Webb Space Telescope will orbit the Sun, stationed far beyond the Moon. There are no spacecraft equipped to send astronauts to it. If anything goes wrong, there's no rescue mission. The telescope is simply out of reach. Adding to the challenge, it only has one onboard camera for internal inspection. That means any damage or malfunction in the harsh vacuum of interplanetary space will have to be assessed blindly from Earth. It's a high-stakes mission where precision is everything and backup options are few. Thankfully, the James Webb Space Telescope is now fully deployed. But it's not ready to start capturing images just yet. Its 18 hexagonal mirror segments must be aligned perfectly to act as one single flawless mirror. That process, known as wavefront sensing and control, will take several painstaking months to complete. But once it's done, the real work begins. Webb already has 286 observation targets lined up. About 70% of these are exoplanets, and thanks to data from previous missions, we already know exactly where to look. The James Webb won't waste any time hunting randomly, it's going straight to the most promising worlds. But what makes James Webb different from Hubble? It's not an optical telescope. It doesn't see visible light like our eyes or traditional telescopes do. Instead, it sees infrared light, heat signatures. That means it can see objects hidden behind cosmic dust, or worlds too faint for visible light detection. When it looks at exoplanets, it won't produce detailed photographs. Rather, we'll see bright fuzzy dots. But these fuzzy dots are packed with information. If the planet has an atmosphere, the telescope can analyze the light passing through it. That's where it gets exciting. By studying that light, its spectrum, scientists can tell what gases are in the planet's atmosphere. If there's methane, oxygen, or carbon dioxide present, those are strong indicators of potential life. The Webb will decode these chemical fingerprints with unprecedented precision. It can reveal temperature ranges, the presence of water vapor, and even the potential for liquid water. From this, scientists can estimate whether a planet is truly habitable, or even already inhabited. It's like building a complete portrait of a planet using only the heat it gives off and the way it filters starlight. And that's not an exaggeration, it's revolutionary. But exoplanets aren't Webb's only mission. It will also study star formation, planetary systems, and the birthplaces of solar systems inside nebulae. Understanding how stars and planets form will give us critical clues about how Earth-like worlds come into existence. But perhaps most thrilling of all, Webb will peer deep into space, farther than any telescope before it. It'll observe the oldest galaxies, those that formed just a few 100 million years after the Big Bang. These galaxies are moving away from us so fast that their light is stretched far beyond the visible spectrum into the infrared. And that's Webb's specialty. By capturing this stretched-out light, the telescope can study galaxies we've never seen before. This could help unlock the mysteries of how the first galaxies formed and evolved. And it may even provide insight into the nature of dark energy, the mysterious force causing the universe to expand at an accelerating rate. There's a real sense of hope that Webb could answer questions we've had for generations. Where did we come from? How did the universe evolve? And ultimately, are we alone in this vast, expanding cosmos? Meanwhile, back on Earth, something extraordinary happens. Hundreds of spaceships lift off, departing Earth's surface and heading toward deep space. But these aren't just science missions. They're diplomatic vessels. Their destination? A location where, for the first time, humanity will encounter not just one, but hundreds of alien ships. It's our first true contact with an extraterrestrial civilization. The place where this momentous encounter is happening? A star system astonishingly close to home, Proxima Centauri. Proxima Centauri is the closest star to our solar system. It's a red dwarf, much smaller and cooler than our Sun. In fact, it's about 7 times smaller and only 50% larger than the planet Jupiter. It's also around 8 times lighter than the Sun. The distance from Earth is just 4.2 light-years, meaning the light we see from that star today left it just over 4 years ago. For comparison, it only takes sunlight about 8 minutes to reach Earth. But traveling to Proxima Centauri with current rocket technology? That would take about 73,000 years, longer than modern human civilization has even existed. But it's not the star itself that has scientists buzzing, it's the planet orbiting it, Proxima Centauri b. This exoplanet is about 177% the size of Earth and roughly 10% heavier. It orbits its star at just 4.5 million miles. That's extremely close. Earth orbits the Sun at 93 million miles. But because Proxima Centauri emits far less light and heat, that close orbit puts the planet in just the right spot. It lies within the habitable zone, the sweet spot where temperatures could allow water to remain liquid on its surface. That makes Proxima be one of the best candidates for life beyond our solar system. But there's a problem, actually several. Observations of Proxima Centauri have revealed that it's an unstable star. Its brightness can change rapidly and not in small ways. In 2017, astronomers witnessed a terrifying event. A sudden flare increased the star's brightness by over 1,000 times in just 10 seconds. Before that, a smaller flare had already been recorded. These flares send massive amounts of radiation toward Proxima b. If any life ever existed there, a flare like that could have destroyed it in moments. Even Earth-like conditions wouldn't be safe from that kind of cosmic assault. In fact, Proxima b receives 400 times more X-rays than Earth does. That level of radiation would be catastrophic for complex life. Even if the planet had oceans and a thick atmosphere, it might not be enough. The constant radiation would likely strip away the atmosphere and boil off surface water. And there's another twist. The planet is tidally locked. That means one side of it always faces its star, just like how the moon always shows one face to Earth. So, one half of Proxima b is in perpetual daylight, bombarded with radiation, while the other side is forever in darkness. And it's in that eternal night where things get interesting. Some scientists speculate that if intelligent life did evolve on Proxima b, it might have retreated to the planet's dark side to escape the deadly flares. Incredibly, that might even tie into something we picked up on Earth. In 2019, astronomers recorded a very strange radio signal, a bright optical flare accompanied by intense, coherent radio bursts. It lasted 30 days and was caught by one of Earth's radio telescopes. Initially, it was thought to be artificial in origin, possibly a signal sent by an intelligent civilization from Proxima b or one of its moons. The scientific community took it seriously. But as time went on, no further signals were detected. Eventually, the main theory became that it was just interference, maybe from Earth-based technology. But still, a haunting question remains: what if it really was a message from a civilization hiding on the dark side of Proxima b? And what if they're still out there, waiting? That's where the James Webb Space Telescope comes back in. Soon it will turn its powerful eye toward Proxima Centauri b. This time we might finally get answers. The telescope could detect atmospheric gases, thermal anomalies, or even artificial signals. And all of this starts when the telescope is launched. It will be carried into space by a powerful booster rocket. Once in orbit, the rocket will deliver the telescope to a special location, a gravitationally stable point between Earth and the Sun. This spot is far from any light pollution, weather, or interference. It's the perfect vantage point for deep space observations. And once it's there, the James Webb Space Telescope will begin its mission, not just to study planets, but possibly to solve the ultimate mystery. Are we alone? Just imagine a boxing ring, but instead of two fighters, it's the James Webb Space Telescope standing face to face with the deepest corners of the universe. With its unmatched capabilities, this telescope can peer so far into space that it catches light from events that haven't even reached Earth yet. This means we'll essentially be looking back in time, seeing cosmic events that happened billions of years ago. The telescope is expected to reveal how the first stars and galaxies formed after the Big Bang, and how everything evolved into the vast universe we see today. That alone is enough to shake the foundation of modern astronomy. But Webb's journey doesn't end with the early universe. It's also pointing its giant golden mirrors toward one of our closest neighbors, Proxima Centauri b. Scientists are using the telescope to scan the planet's night side for traces of artificial light, similar to the LED lights we use on Earth. If life exists there, especially on the dark side, its inhabitants would need to transfer heat and possibly even light from the day side to survive. That would most likely involve some form of artificial illumination, which the James Webb Telescope might actually detect, distinguishing it from the natural starlight. Detecting such light could become humanity's first indirect evidence of an intelligent extraterrestrial civilization. But astronomers are cautious. Data can be misread, and even the most promising signals may turn out to be false positives. That's why, despite the power of Webb, the only surefire way to confirm life out there would be to send a probe directly to Proxima Centauri. The issue, however, is distance. Even though Proxima is our closest stellar neighbor, it's still 4.24 light-years away. That's a monumental distance. For comparison, Voyager 1, which took over 4 decades just to exit our solar system, didn't even come close to that. Given this daunting distance, conventional space travel isn't going to cut it. That's why researchers are eyeing more radical ideas. One such plan involves deploying microprobes, each no heavier than a sewing needle. Thousands of them would be launched into space using a powerful vehicle, and once in orbit, each would unfurl an ultralight space sail. This sail would catch light from a focused laser beam on Earth, propelling the probes to speeds of about 20% the speed of light. That would be the fastest man-made object ever. Even so, reaching Proxima would still take around 21 years, and we'd have to wait another 4 years for the first signal to return. Yet Proxima isn't our only hope. Webb is also scanning other parts of the cosmos for habitable worlds. Its powerful instruments are tuned to detect relatively cold exoplanets, planets that have temperatures similar to Earth's. In fact, Webb is set to study about 24 nearby star systems in great detail. It won't just detect new planets but also potentially their moons. This could be a game-changer, especially if some of those moons exhibit Earth-like environments. Scientists believe that with every new discovery, we inch closer to identifying worlds that might host life, or at the very least, offer conditions for future human habitation. Back here in our own solar system, Webb's talents are equally valuable. Take Jupiter's moon Europa, for example. While it appears as a frozen wasteland, scientists believe a subsurface ocean exists beneath its icy crust, heated by the gravitational pull from Jupiter. This internal heating might create a hidden environment where microbial life could thrive. Similarly, Saturn's moon Enceladus has geysers that erupt from cracks in its surface, another sign of internal activity. Webb's infrared sensors will scan these moons for biosignatures, chemical traces that could point to life, whether bacteria or something more complex. While the James Webb Telescope has a planned operational span of about 6 years, humanity's thirst for discovery won't stop there. Already, preparations are underway for a successor, a telescope called LUVOIR, short for Large UV Optical Infrared Surveyor. LUVOIR's mirror will be massive, twice the diameter of Webb's and almost 7 times larger than the Hubble's. Scheduled for launch around 2039, it'll ride aboard a super heavy-lift rocket and travel to a distant orbital position roughly 1 million miles from Earth. With this behemoth of a telescope, we'll probe even deeper into space with sharper detail and broader reach. If technology continues advancing at its current pace, who knows? By the time LUVOIR is in orbit, we might have cracked the secret to faster-than-light travel. Then, Sending human explorers to distant exoplanets could move from science fiction to
These
science
cosmic
fiction.
events essentially happen
Imagine a
billions
team
of
of
years ago.
astronauts, scientists, and diplomats boarding a vessel to meet an alien civilization discovered by Webb or Louvre. A true interstellar meeting, not just of minds but of species. That possibility, however distant, pushes us to keep asking the big questions and pushing the boundaries of what's possible. As you stand outside on a quiet night looking up at the stars, think about this. While we search for life in the cosmos, there might be someone out there doing the same. And not just randomly scanning space, they could be specifically watching us. According to scientists, at least 29 planets in distant solar systems may be observing Earth right now. So maybe comb your hair, put on a smile, we might be on camera. So far, astronomers have identified 1,715 nearby star systems in the Milky Way that could detect Earth using their own telescopes. These stars are all in our galactic neighborhood, and if their observers were watching our sun, they would eventually notice a small dot, Earth, passing in front of it. This is known as a transit, and it's a primary method for detecting planets in astronomy. You can even observe a transit at home if you have a solar telescope. Just point it at the sun and wait. Mercury, the closest planet to the sun, will show up as a small dot crossing the solar disk. The entire event can last up to 5 hours and happens around 14 times every century. The next Mercury transit is scheduled for November 13, 2032. Venus also transits the Sun, though it's a rarer event due to its different orbit. The last Venus transits were in 2004 and 2012. If you missed those, you're in for a long wait. The next pair won't occur until 2117 and 2125. So, these distant alien star systems would observe Earth in a similar way. But unlike our view of a dot crossing the Sun, their advanced telescopes would measure subtle dips in the brightness of our star when Earth passes in front. By analyzing that drop, they could estimate the size of our planet and potentially detect signs of an atmosphere or even pollutants, possible markers of civilization. Of course, not all of the 700+ systems are likely homes to alien life. But scientists have zeroed in on 29 planets near these stars that lie in the habitable zone. That means they're just the right distance from their stars, neither too hot nor too cold. If the planet is too close, water would boil away, too far and it would freeze. These 29 planets have orbits that would have allowed them to see Earth's transit in the last 5,000 years. That's right, while humans were building the pyramids or aligning Stonehenge with the stars, it's entirely possible that alien astronomers were watching us through their own telescopes. One such planet orbits the star Ross 128, just 11 light-years away in the Virgo constellation. It's about twice the size of Earth and comfortably nestled in the habitable zone. For a solid 2,000 years, it would have been able to observe Earth's transits. But around 900 years ago, due to orbital shifts, the opportunity to watch Earth disappeared. Another candidate lies 12.5 light-years away near the Teegarden star. The window to observe Earth from there is opening soon, about 29 years from now. So perhaps in a few decades, eyes from Teegarden's world will once again turn toward our little blue dot. 4 years, scientists have had their eyes locked on the TRAPPIST-1 star system. This unique system is home to at least 7 exoplanets, arranged somewhat like our own solar system. Even more fascinating is that 4 of those planets sit in the habitable zone, where conditions might support life. Unfortunately, they won't be in a position to observe Earth for another 1,600 years. But that doesn't mean we have to wait. Thanks to our own technology, we can attempt contact right now. These planets are still close enough that our radio waves traveling at light speed could already be reaching them. Earth has been blasting out radio signals into space since as far back as 1895. That means our planet has been a noisy neighbor in the vast radio spectrum for over a century. Any civilization within about 25 light-years could already be picking up our transmissions. The catch: if they reply, we'd need to wait the same number of years to hear back. That makes communication frustratingly slow. Plus, there's another issue. Radio waves might not even be used by alien civilizations. They may rely on entirely different technologies or skip radio altogether, just like we moved to Bluetooth and fiber optics. The reality is that even here on Earth, radio is gradually fading out. Sure, it still powers things like traffic reports, but for the most part, it's no longer our primary communication method. So, there's a slim window during which a civilization could catch us using radio. They'd need the right technology at just the right time. Otherwise, our signals might pass by unnoticed. Still, that hasn't stopped us from trying. We've actively sent signals into space, like the famous Arecibo message from 1974. That was a bold attempt to say hello to any intelligent life that might be listening. The Arecibo message wasn't just random noise. It was a carefully structured broadcast, encoded in binary, meant to be decoded into a visual grid. The top section of the message contains numbers, followed by atomic numbers, then a representation of our DNA. Below that is a stick figure of a human, alongside a depiction of our solar system, with Earth slightly raised to indicate it's our home. At the bottom is a diagram of the Arecibo telescope itself. If any intelligent civilization receives it and deciphers the code, they'll have a solid introduction to who we are and where we're from. But we didn't stop with radio. We've also tried a more tangible form of communication, sending literal mail into the cosmos. That's where Voyager 1 and 2 come in. These spacecraft, launched in 1977, carry what's known as the Golden Record. This metal disc is like a time capsule of humanity. It contains greetings in 55 languages, a variety of music from around the globe, and sounds like thunder, ocean waves, and even animal calls. There are also 116 images showing life on Earth, from landscapes and people to scientific data like the structure of DNA and maps of our solar system. Each Golden Record was designed with extraterrestrials in mind. The case includes a stylus and instructions on how to play it. And to help alien astronomers figure out where the spacecraft came from, the records include a diagram showing the position of 14 pulsars in our galaxy. Pulsars have extremely precise frequencies, so they're like cosmic signposts. Using this map, a technologically advanced species could trace the signal back to our solar system. It's a beautifully thought-out plan, except for one major flaw: time. Voyager 1's first possible star encounter won't happen for another 40,000 years. To put that in perspective, Voyager 1 is on course to pass by the Gliese 445 star in about 40,000 years. Voyager 2, its sibling, will fly by Ross 248 in roughly 42,000 years. And Sirius, the brightest star in our night sky? That encounter won't happen for almost 296,000 years. That's like mailing a letter and waiting for a reply in the next ice age. Even so, it's better than nothing. There's also the possibility that an advanced civilization could detect us not through our messages, but by observing our sun and its slight movements caused by orbiting planets. Here's how it works. A star doesn't just sit motionless while planets orbit it. The gravity of a planet tugs on its star, causing the star to wobble slightly. This tiny shift can be measured, and from it, scientists can calculate the mass of orbiting planets. It's how we've already discovered over 500 exoplanets. If an alien civilization were watching our sun closely, they could detect this same wobble and realize that planets, possibly even Earth, are orbiting it. With enough observation, they could estimate where Earth is, its size, and whether it might harbor life. Now imagine this: we actually get a message back from a planet orbiting Proxima Centauri, the closest star to our solar system. It's an exciting thought, but also a bit depressing. Proxima b, the exoplanet in that system, is likely bathed in deadly radiation from its star, making life unlikely. Still, suppose we somehow receive a response. It would mark the slowest conversation in history. Our message would take 4.2 years to reach them, and their reply would take another 4.2 years. Just one hello and response would span nearly a decade. Let's go one step further. What if we decided to visit? We know they can't travel to us, so we have to make the first move. But even though Proxima Centauri is the closest star, it's still incredibly far, over 4 light-years away. Using conventional rocket technology, it would take us about 73,000 years to get there. That's longer than all of recorded human history. Even if we could travel at light speed, it would still be a 4.2-year journey. It's like trying to visit a neighbor by walking across a continent. Now imagine the alien world we want to reach isn't near Proxima Centauri, but on the far side of the Milky Way. Our galaxy stretches over 100,000 light-years across. If we attempted a trip across that vast distance, it would take 100,000 years even at light speed. So our only real options would be to either break the laws of physics, perhaps through concepts like warp drives or wormholes, or to pack humanity onto a massive interstellar ship. That vessel would need to sustain generations of humans over millennia, with only distant descendants seeing another star system. Picture that for a moment. A ship leaves Earth today, and as it travels, generations live and die aboard it. Those born at launch would never see the destination. It's only their great-great-great-great-great-grandchildren, dozens of greats down the line, who would one day peer through the ship's windows to glimpse a new sun rising. It's a journey unlike any humanity has ever faced, but one that could redefine who we are. All the while, someone might be trying to get a better view and asking, "Hey, can you move your head? I'm trying to see out the window." Enter the James Webb Space Telescope, one of the most sophisticated instruments humanity has ever built. Designed to surpass even the legendary Hubble, it's already delivering jaw-dropping results. In one instance, it detected a faint glow from a mind-bending 7 trillion miles away. Some speculate this glow might even be city lights from an alien civilization. That's a huge leap, but to unpack this we need to go back a few years. That's when NASA's Spitzer Space Telescope first identified a special star system, TRAPPIST-1, home to 7 rocky exoplanets that immediately captured global attention. Recently, the James Webb Telescope took things a step further. Using its advanced infrared technology, it measured the temperature of one of those planets, TRAPPIST-1b. Sadly, the results weren't promising. While the planet was rocky and Earth-like in size, it was far from habitable. Astronomers used the MIRI instrument, which essentially gives them thermal heat vision, to read the planet's emissions. What they found was intense heat, about 450 degrees Fahrenheit. That's like standing inside an oven. And worse still, there's no detectable atmosphere on the planet, making the idea of life there nearly impossible. Still, this discovery wasn't a failure, it was groundbreaking. This marked the first time scientists had been able to measure any kind of light from such a small, relatively cool exoplanet. Previous telescopes lacked the sensitivity to detect this kind of faint mid-infrared glow. And while TRAPPIST-1b turned out to be inhospitable, the larger significance is that James Webb proved it could gather data at that level. That opens up a whole new era of planet hunting, especially when it comes to small rocky worlds. The technology is finally here to peer into their atmospheres and assess their habitability. When the TRAPPIST-1 planets were first discovered, astronomers were ecstatic. All 7 were Earth-sized and located within a star's habitable zone, the sweet spot where water could exist. But there's a catch. These planets are located 235 trillion miles away. Even more challenging, TRAPPIST-1 is a red dwarf, also known as an M-dwarf star. These types of stars are extremely common in our galaxy, twice as abundant as Sun-like stars. They're also more likely to host rocky planets, which is why they're a favorite target for astronomers looking for signs of life. But M-dwarf stars come with serious drawbacks. They're more active than our Sun and frequently emit powerful solar flares. These bursts of radiation can strip away a planet's atmosphere or prevent one from forming entirely. When researchers first studied TRAPPIST-1b, they couldn't confirm whether the planet had an atmosphere. Now, thanks to the James Webb Telescope, we know that it doesn't. That's a huge setback in the search for habitable exoplanets around M-dwarfs. One of the key indicators was that the planet is tidally locked, meaning one side always faces the star and the other side remains in darkness. If TRAPPIST-1b had an atmosphere, heat from the sunlit side would have been distributed more evenly. That would have resulted in lower average temperatures. But James Webb's findings showed the exact opposite. Temperatures were scorching hot. That suggests the planet has no atmosphere to redistribute heat. And with that conclusion, scientists have to cross TRAPPIST-1b off the list of potentially habitable worlds. However, the real victory here isn't the loss of one planet. It's the fact that we now have a telescope that can make these detailed observations. And with that, the search for life continues. One day, NASA might build a spaceship powerful enough to take us far beyond our solar system. Anywhere in the universe, really. When that moment arrives, humanity could finally find a new, beautiful world to call home. Scientists already have a checklist for this perfect planet. Ideally, it should be about twice the size of Earth, with an average surface temperature of 77 degrees Fahrenheit. It also needs a thick, protective atmosphere. A larger planet would provide more space, more water, and more opportunities for diverse ecosystems, while a dense atmosphere could shield us from harmful radiation and support lush vegetation and exotic wildlife. Thanks to the powerful James Webb Space Telescope, we now have the ability to study distant exoplanets like never before. From hundreds or even thousands of light years away, we can analyze their atmospheres, temperature, and potential for supporting life. Of course, nothing compares to physically sending astronauts to explore these planets up close. But for now, our telescopes are doing a pretty decent job. Still, discovering new planets is no small feat. It's like trying to spot a single firefly flickering in the heart of a pitch-black forest. That's how challenging it is to detect a world orbiting a distant star. To overcome this challenge, scientists developed a clever approach called the transit method. Here's how it works. Astronomers take a series of snapshots of a distant star over time and examine those images for any strange, periodic dimming. If a dark spot repeatedly crosses in front of the star, it could very well be a planet passing by, just like a bug briefly covering a flashlight beam. These observations reveal more than just the presence of a planet. They can also tell us its size, radius, and distance from its host star, and most intriguingly whether it might one day support human life. And this method is paying off. Not too long ago, astronomers spotted a fascinating new world hidden in the constellation Cygnus. They named it Kepler-22b. At first glance it may not seem extraordinary. But this small discovery has triggered enormous excitement within the scientific community. Why? Because Kepler-22b lies in the Goldilocks zone, a region around a star where conditions are just right for liquid water to exist on a planet's surface. Not too hot, not too cold, just right. That's crucial because where there's water, there's a real chance for life to emerge and thrive. A planet covered in water wouldn't just be biologically interesting, it could also be climatologically stable. Large oceans regulate a planet's temperature, absorbing heat from hotter areas and redistributing it to cooler regions. It's like having a global thermostat built into the surface. Back when Earth was still young and violent, it was the moon's gravitational pull that helped spread Earth's water and kickstart the conditions necessary for life. If Kepler-22b has similar mechanisms or vast oceans, it could be just as promising. And here's something amazing, it orbits its star in about the same time Earth does. 1 year. And if all the speculations about oceans on Kepler-22b turn out to be true, its average temperature might hover around 12 degrees Fahrenheit. That's chilly but not unbearable. Even better, if this world possesses an atmosphere similar to Earth's, the temperature could rise to a cozy 72 degrees Fahrenheit, perfect for supporting diverse life forms. The planet is relatively close, too, just 635 light-years away, which translates to about 3 quadrillion miles. While that sounds like a massive distance in cosmic terms, it's surprisingly close. Its host star is a yellow dwarf, much like our Sun, although it's about 20% dimmer and cooler. You won't be spotting this dim star with the naked eye, no matter how hard you squint at the night sky. It's simply too faint to be seen from Earth. Its surface temperature is roughly 10,000 degrees Fahrenheit, making it a kind of chilly outlier among stars. Fortunately, Kepler-22b orbits much closer to its star than Earth does to the Sun. If this planet were part of our solar system, it would be located somewhere between Earth and Venus. That placement gives it roughly the same levels of light and warmth as Earth receives today, which is very encouraging for the habitability prospects. But there are potential downsides. For one, Kepler-22b might have an unusual axial tilt, possibly similar to Uranus. That would mean the planet spins in a strange way, causing extreme seasonal swings. Imagine bone-numbing winters followed by unbearable summers. Such climate instability would make it difficult for any life, including humans, to adapt. Let's just hope the planet has a stable tilt like Earth does. If that's the case, then the climate could be pleasantly familiar, ideal for potential colonization. But even if the climate cooperates, the planet's gravity presents a new set of challenges. Kepler-22b is roughly 2.4 times the size of Earth, so its gravitational pull would be significantly stronger. Everything would feel heavier. Just climbing stairs would feel like hiking up a mountain with weights strapped to your back. Even simple activities would drain more energy and just breathing might take more effort. Humans living there would need stronger bones, bigger lungs, and hardier cardiovascular systems. Physical adaptation would be necessary. On the flip side, the higher calorie burn could mean one fun thing: you get to eat more food without gaining weight. Every workout comes with a buffet reward. Buildings would also need a complete redesign. Tall skyscrapers might be impossible due to gravitational stress. Most architecture would be squat, square, and solid, like bunkers built to withstand pressure. Lightweight materials wouldn't cut it. Engineering would become a whole new field, and every structure would need to be carefully designed to resist collapse under its own weight. But even before we think of construction plans, we have to ask, what kind of planet is Kepler-22b really? This is the biggest unknown. Scientists still aren't sure whether it's a rocky world like Earth, or something entirely different. It could be a gas giant or a water world, a planet submerged beneath unimaginably deep oceans with no solid land in sight. Not just regular oceans either, we're talking about water thousands of miles deep, extending far below what we know on Earth. There would be no beaches, no trees, no visible land. If that's the case, we might have to build massive floating or even underwater cities. We could filter the ocean water for resources and adapt ourselves over generations, maybe even evolving into aquatic or amphibious beings. Sounds wild, but it might be our next evolutionary leap. Some researchers believe Kepler-22b could also be a mini Neptune, a category of planet smaller than our solar system's Neptune but still gassy and inhospitable. However, that's still a theory not confirmed. Let's say, just for the sake of optimism, it is a rocky planet. Even then, there's a lot we don't know. Does it even have an atmosphere? If so, what's it made of? What if it's like Venus, filled with carbon dioxide and sulfuric acid clouds, toxic enough to ruin your day faster than any breakup ever could? We'd have to dig into the crust for shelter and geothermal heat. But let's stay hopeful and assume Kepler-22b has an Earth-like atmosphere. What would that world actually look like? Due to stronger gravity, its terrain might be more rugged, steeper mountains, deeper valleys, and faster rivers. Any life forms that exist would probably be small and stocky, evolved to deal with the intense gravitational forces. Trees would likely be thick and low, clinging tightly to the soil. Tall plants would struggle to grow. Animals might also be short and muscular, built for strength over elegance. Imagine creatures with thick legs, multiple limbs, and dense bones, designed purely for survival, not grace. Even our favorite animals, like dogs or cats, would have to change dramatically to thrive. They'd need stronger hearts, bulkier bodies, and more muscle mass just to move around. Pets might look like tiny bodybuilders. Birds might not even exist if flight proves too energy-intensive in stronger gravity. Even walking around could feel like a slow-motion workout. On a planet that big, distances would be mind-boggling. A simple cross-country trip might take 3 days by plane. But hey, space travel isn't about convenience, it's about adaptation and resilience. And Kepler-22b is shaping up to be the ultimate test of both. There are still tons of mysteries surrounding this planet. And yet, the possibilities are thrilling. One day we might send our first astronauts there, ready to explore a world we've only seen as a faint blip of light. But imagine the irony if we get all the way there, only to discover it's a gas planet with nothing to land on. That would be a very expensive whoops. Still, we keep searching. Okay, quick space riddle. Why is the search for life like a tree? Because you're always looking for a place to plant it. Get it? Plant it? Anyway, jokes aside, water remains the golden ticket for life in the universe. Without liquid water, life as we know it can't thrive. For water to exist on a planet's surface, a perfect balance of conditions is required. The planet must lie in the habitable zone of its star. Too close and water evaporates, like on Venus where surface temperatures cook anything that dares to land. Too far and water freezes, locking any chance of life beneath icy crusts. Some planets like Neptune may have liquid water deep inside, but surface conditions are too harsh for life to emerge in any known form. In addition to being in the habitable zone, a planet must also meet some specific conditions to support life. It must be a solid planet with a stable surface, not just a gas giant. More importantly, it needs to have an atmosphere thick enough to shield its surface from harmful solar radiation, and breathable enough to support life as we understand it. Inside our galaxy alone, there are countless stars, so many in fact that it's impossible to truly count them. And near almost every one of these stars there could be planets orbiting, known as exoplanets, each with the potential to host life. Among the more than 4,500 known exoplanets, scientists have identified 24 that are not just habitable, but superhabitable. These aren't just Earth-like, they might be even better than Earth when it comes to supporting life. Superhabitable planets must be at least twice as massive and 1.3 times larger in diameter than Earth. That larger size creates stronger gravity, which can help retain a denser, warmer atmosphere. This thicker atmosphere can offer a better shield against radiation and climate extremes, creating a stable environment for a greater variety of living organisms to evolve and thrive. Another crucial factor in determining whether a planet can support life is the star it orbits. Ideally, a superhabitable planet should orbit a star smaller and longer-lived than our Sun. Stars like our Sun live for under 10 billion years, and it already took Earth nearly 4 billion years to develop complex life. That doesn't leave a huge margin of error. But stars like red dwarfs or K-dwarfs can last between 15 and 70 billion years, providing a much longer window for life to begin and evolve. These longer-living stars might be the best bet for supporting advanced civilizations. Of course, these long-lived stars often shine dimmer than the Sun, meaning their habitable zones are closer in. But that could work in our favor. Smaller stars are also less likely to produce deadly radiation bursts if they're relatively calm. Ideally, a planet orbiting such a star would have higher humidity, an average temperature about 8 degrees Fahrenheit warmer than Earth's, and a climate that resembles Earth's tropical forests, lush, diverse, and teeming with life. These conditions are considered the most favorable for biodiversity, giving rise to an ecosystem possibly more advanced than our own. The 24 superhabitable candidates scientists have identified so far are all located more than 100 light-years away from Earth. But with next-generation space telescopes, we may soon be able to analyze their atmospheres and surfaces in detail. that could confirm whether these planets are not just suitable for life, but potentially already inhabited. Now let's take a closer look at some of these remarkable worlds. The first is Teegarden b, a planet that orbits a calm red dwarf star just 12 light-years away. Unlike many red dwarfs, this one doesn't emit dangerous flares, so its planets are safer. Teegarden b is nearly identical to Earth in mass, and it completes one orbit around its star in just 5 Earth days. Yes, you heard that right. A full year on Teegarden b is less than a week for us. Now that's a fast calendar. Moving on to the most distant potentially habitable exoplanet known, Kepler 1638b. It's located a staggering 3,000 light-years away in the constellation Cygnus. This super-Earth is twice the size of Earth and 4 times as heavy. Its intense gravity would make every step feel like a burden, and a simple jump would be incredibly hard for us. But if there is life on Kepler 1638b, then the organisms there would have naturally adapted to these intense conditions. Next, we look at LHS 1140b, a rocky and incredibly dense world. Though it's only 40% larger than Earth in diameter, it's 7 times more massive. That gives it a surface gravity of around 3.25 gs. To compare, when you take off on an airplane, the maximum g-force is usually around 1.5. On LHS 1140b, you'd probably collapse to the ground without support. But this extreme mass also gives it a thick atmosphere and a temperature above 19 degrees Fahrenheit thanks to the greenhouse effect. Its orbit is quite tight. It revolves around its star in just 24 days. Now let's shift our gaze to the constellation Aquarius, home to the TRAPPIST-1 system. This system includes several planets in the habitable zone of an ultra-cool dwarf star. One of the standout candidates is small, 3 times lighter than Earth, and has a temperature similar to our own. Its gravity is about half that of Earth's, making it feel like walking on the moon. If you remember how astronauts bounced around up there, well, that's exactly how movement would feel on this world. Next is Kepler 452b, often dubbed Earth's older sister. It's located in a solar system very similar to ours. The host star is just 11% larger than our Sun and about 2 billion years older. The planet itself is about 6.5 billion years old, making it significantly older than Earth. That extra time could have allowed for more advanced evolutionary processes to take place. However, there's a catch: it's incredibly far away. Even traveling at the speed of NASA's New Horizons probe, which is over 36,000 miles per hour, it would still take around 26 million years to reach it. So, pack a big lunch. Then there's Proxima Centauri b, the closest potentially habitable exoplanet to Earth. It orbits Proxima Centauri, the star nearest to our solar system, at just 4.2 light-years away. It has a similar mass and size to Earth and might have a cold, icy surface similar to Neptune. But even though Proxima Centauri is our nearest stellar neighbor, you can't see it with the naked eye because it's simply too dim. That just shows how much of our cosmic neighborhood remains hidden from ordinary view, yet full of untapped possibilities for discovery, exploration, and maybe even colonization one day. All of these planets, including the 24 superhabitable ones, are located in the habitable zones of their stars. In theory, that means they could host life. And in the distant future, they might even be suitable for human colonization. But here's the catch: they're far. Really far. Even the closest one, Proxima Centauri b, is beyond the reach of current space travel. Our fastest rockets today move at about 5 times the speed of sound, which sounds fast, until you do the math. At that speed, it would still take us more than 100,000 years just to reach Proxima Centauri. So what's the solution? We need a faster way to travel, much faster. Scientists are now turning to ideas that once belonged only to the realm of science fiction. One such concept is the warp drive. This theoretical technology involves bending space-time itself, creating a kind of bubble around a spacecraft in which the usual laws of motion don't apply. In this bubble, space contracts in front and expands behind, propelling the spacecraft forward faster than light without technically violating the laws of physics. While no physical object with mass can exceed the speed of light, a warp bubble might circumvent that limitation. Surprisingly, this idea isn't just a fantasy anymore. It's being seriously studied. In theory, such a ship could travel at up to 10 times the speed of light. But there are challenges. First, the spacecraft would need to be massive. Second, the energy required to power a warp bubble is mind-boggling, close to what an entire planet like Jupiter generates. However, there's some promising news. Recent research from NASA's Jet Propulsion Laboratory has suggested a breakthrough. The warp ring, which generates the warp field, doesn't need to be perfectly round. A donut-like shape could make construction far simpler and much more feasible. This new shape reduces the energy requirements and could allow for testing the concept on a small spacecraft, maybe even one the size of Voyager 1. So while warp drives still feel like a dream, scientists believe we are inching closer to turning it into reality. And that's not all. NASA already has long-term plans to venture beyond our solar system. In fact, the agency aims to launch its first interstellar mission by the year 2069. The goal? To explore planets that might be habitable beyond our own star system. It's ambitious, but it's not impossible. Meanwhile, alternative technologies are also being explored. For instance, laser propulsion is being tested, especially for tiny spacecrafts. If the probes are light enough, powerful lasers on Earth could propel them at nearly the speed of light. One such concept could send a microprobe to Alpha Centauri in just a couple of decades. Other theoretical power sources include nuclear fusion and matter-antimatter collisions, which could provide immense energy output. But these remain more speculative for now. Until then, all we can do is dream, explore with telescopes, and keep pushing the boundaries of what's possible. So stay tuned, because humanity's greatest journey may just be beginning.